In this problem we have someone rowing a boat right here, and the idea is, where should they come ashore to then jog the rest of the way to the destination? Here is the destination over here. So they want to end up. So the idea is, do they row here and then jog all the way over there? Or do they do like this picture says, go over here, row a long time in the water, and then jog over there? So that's going to be the problem, because also in the mix here is that the rowing speed is 3 miles per hour, and the jogging speed is 6 miles an hour. And the idea is that we want to minimize the time. It says, at what point along the shore should he beach the boat and jog the rest of the way if he wants to get home as soon as possible? So that's the idea of minimizing the time. Okay, so we set up, call this x here, the distance from here to where he's going to beach the boat and land the boat. So then 17 minus x is the rest of the way, because the whole distance over here is 17 miles. Alright, so we have to figure out how far is this distance here. So the Pythagorean theorem says that 3 squared plus x squared is this d squared, so d will equal the square root of x squared plus 9. And then we have the distance of jogging is 17 minus x. So this is rowing, and this is jogging. So we're minimizing the time. So time is distance over rate. So the time in the boat is the distance over the rate, and that's miles over miles per hour, which does lead to hours when it cancels out there. So it's the right units. Then the jogging, the time of the jogging is 17 minus x over 6 miles an hour. So the total time up over here is t is equal to the time in the boat plus the time in the jogging, which is this function plus this one. So that's the total time. So we want to minimize it. Well, it sure would be handy right now to have some calculus, but we haven't learned calculus yet. So we're just going to have to do a graphing calculator method. So we put the function into the calculator. When you graph it, depending on what window, you have a hard time seeing where the minimum is. So what I did was I made a table, and I saw that the values started at 3 for 0, and they went down a little bit, and then they came back up. So right around in here is where the minimum is, somewhere in there. So then I set the window to be able to see that, and then I got this curve here, and I'm looking at this minimum here. Then I did a second calc minimum, second calc min, capture that point, and it was x is 1.7320495, which produced a time of 3.699 hours, and this is miles on the shore. So really, the bottom line is that the boat should come pretty quickly to the shore and then jog the rest of the way, because the jogging speed is so much faster than the rowing speed. So it's a good idea to get out of the water as soon as possible, or almost as soon as possible, and then jog the rest of the way.